Good afternoon. I am José María Esbrí, and I am going to present a work in a similar way that the previous work. We are working in Alcudia Valley and surrounding areas related to historic lead and zinc and silver mining in this area in the last 2 years, but our point of view is a geochemical point of view. We center our work in soils and in heavy metal contents in these soils, and bioavailability of these heavy metals, leachability of these heavy metals, and the transfer of these heavy metals to plants. Our working area is similar like the previous work, but we work not only in the Alcudia Valley, but in all of the southwest of Castilla-La Mancha. This is a big geochemical anomaly in soils in the last geochemical atlas of Institute of Geology of Spain. We can see that in lead, in the topsoil, the high contents of lead in this area, or in zinc, for example, the high content of sediments in this area of Ciudad Real, and the south of Toledo, not only Alcudia Valley. Mining in this area is active since Roman times, with an important peak during the 19th and first half of the 20th centuries. Most of these mines have closed before 1980, but these mines were not affected by restrictive legislation, and they were abandoned without any restoration works. We make geochemical sampling of soil, sediments, waters, and if we can almost plant of the area, we use regular grids of sampling of soil samplings in I think 10 mines. In other mines, we sample all of materials of small mines, spoil heaps, metallurgical residues, or soils around these areas. This is 3 examples of our work in this area, in Guadalmez and La Romanilla in Alcudia Valley. Not only La Romanilla is in Alcudia Valley, Guadalmez is at the south of Almadén, and one of these sampling area is in Mazarambroz, some of 30 kilometers south of Toledo, of this city. We sample oak tree leaves, of recent leaves, and ancient leaves of mining areas and surrounding areas, and blank areas in San Quintin mine, in La Romanilla group of mines at the south of Brazatortas, and in Guadalmez and in Bombita mine. For soil characterization, we measure main pedological parameters: pH, conductivity, particle size, organic matter, to characterize these materials from the mine and the agricultural soils in the surrounding area. Determination of heavy metal contents of total trace elements on soils and oak tree leaves was performed by XRF, a portable equipment and laboratory equipment on our laboratories, and by ICP-MS on this city. Accuracy and precision of XRF was enough to a previous knowledge of our samples, but in most of the elements we have not enough accuracy and precision to determine this element. This is the reason because we use ICP-MS to determine heavy metals in soils and on plant samples. But the correlation between the two techniques were very acceptable. But XRF underestimated some heavy metals, and ICP-MS have higher accuracy and precision rate. This is for total contents of heavy metals in soils and plants, but we wanted to know the levels of this heavy metal that was easily leachable and easily bioavailable to plants and to the plants. We use 4 methods to do this. These two methods to study the leachability of soil samples, and these 2 methods to evaluate the bioavailability of heavy metals in our samples. The dissolved metals with these extractants were determined by ICP-MS. In oak tree leaves, we make not only total content of heavy metal, but we make only total content of heavy metals, and we make the quality control of measurement with duplicate samples, blanks, and 35 reference materials to each matrix sample. The results, we found that levels of lead and zinc in the study area, in all of the mines where we were working, and were in the range of 1,000 to 10,000 milligram per kilogram. And this is an example of Mazarambroz mine. In this mine, maximum levels reach 1,000 in lead, in total lead, more than 1,000 in zinc, but in copper and arsenic, the levels are quite lower. And the extension of contamination around the mine area is not wide. Some 500 meters, 1 kilometer away of the study area, the levels of agricultural soils are quite low. But we found levels in anthracite and technisol higher than 60,000, 16,000 milligram per kilo of lead and zinc, respectively. But in agricultural soils in the surrounding area, the levels are quite lower, below 100 of milligram per kilo in these soils. This is another example of this geochemical work in Guadalmez, in the south of Almadén. and in San Quintin mine. These maps express not only levels of these heavy metals, but the areas that have concentration up to a reference level that we calculated in a control area in the Alcudia Valley. In these figures, we can see that the contaminated soils in the study area are not very large. The extension are not far than 1 kilometer from the mine, but the mine is affecting the soils in the surrounding of this mine in Guadalmedina or this mine in San Quintin. Sediments affected by acid mine drainage generation, especially in San Quintin mine. This is San Quintin mine. We work in this area of the mine, and this is the river with levels of pH between 3.2 and 7, with lower values near the mine, and with higher heavy metal contents of copper in this area. Copper is more mobile than lead, for example, and copper you can find the higher levels in the confluence with a major river, but lead you can find the higher levels near the mine, because lead is less mobile element in this paragenesis. We also found difference in leachability capacity for each heavy metal. We found leachability higher of lead in abandoned mine without acid mine drainage, and not in San Quintin, but in La Romanilla or Guadalmedina. And this mine have waste deposit, and where waste deposits are remobilized to be used as construction materials, for instance, in La Romanilla group of mines. Thin leachability were higher in mines with active acid mine drainage, like San Quintin group of mines. And this is the results of the first method. The second method, this group of results was higher than the others. And we found that lead viability was similar in all studied mines. We don't have statistical significance difference in each group of mines of lead, but thin viability was higher in mines with active acid mine drainage. Thin is more mobile element than the other, and this may be the explanation for this data. I thought all of these mines are quite similar in terms of ore mineralogy, and are located in similar geological contents. Translocation of these heavy metals from soils to plants shows a strong heterogeneity. For instance, we can see the correlation rates square of lead, for example, with the four methods to study viability and leachability of these soils. We don't have a higher correlation for San Quintin mine and La Romanilla mine. We have the higher correlation in Guadalmedina. In this mine, we don't have acid mine drainage. We don't have a metallurgical plant, and the materials are not being used for other uses. In zinc, we have a higher correlation for Guadalmez and La Romanilla. In these two mines, we don't have acid mine drainage, but in San Quintin, with lower correlation, we have acid mine drainage. Many factors affect this translocation process, seems to have an important influence on plant uptake, difference in leachability and viability were observed and characterized on this work. Present absence of flotation smelting plants seems to be important. Organic matter contents, active acid mine drainage generation, and recycling of waste material for constructive purpose or change on land use of abandoned mines. If we focus the analysis on homogeneous group of mines like Guadalmez and La Romanilla without AMD, we found a good correlation between bioavailable contents, this and this, especially particular for zinc, cadmium, arsenic, copper, lead, and silver. Correlation are not so high, but in natural environment, we think it's sufficient, especially, for instance, for silver in La Romanilla mine. Our conclusions are that long-term active lead, zinc, silver mining has left a legacy of a huge volume of contaminated waste on the southeast of Castilla-La Mancha region, especially concerning lead and zinc. These heavy metal reach higher levels on the vicinity of these mines, but also have an important influence on higher local background levels. A generation of AMD, remobilization of waste dump, and presence of concentration plants on each group of mines cause a significant difference in leachability and viability of analysis metals, and plant uptake appears as a more complex scenario and seems to be dependent not only by these factors, but also on plant physiology. We don't know so much about this, and pedological parameters and land use. Thank you.
Thank you very much.